Hello and welcome to Zero to Game Dev Hero. Today we will learn how to implement a time counter into our game. This will be useful to automatically spawn a pipe every few seconds for as long as our bird is flying. In the original game, the pipes spawn somewhere out of the screen and then move into the viewport. The world is not pre-built. It's different every time and never ends. Let's rebuild this mechanic. First, let's give our pipe a constant movement to the left. We have already learned how to implement something similar, so you can pause the video and first try to implement the movement by yourself. I hope you are successful. Now let's do that together. We can create a new component on our pipe and call it constant movement. To do that, we go to our prefabs folder, select our pipe, double click on that. Make sure you're on the main object of your pipe, so the pipe object here, and click on Add Component. Here you can add a component with the name Constant Movement. Create an add, and then open it. Inside the component's update method, we can write transform.position plus equals new vector 3, and inside the vector 3 we can write minus 0.01 f 0, 0. So it moves on the x-axis in a negative direction. We can multiply this direction by a speed. So we can write here times speed, and we can create the speed variable at the top. So let's write float speed and expose it to the editor with serialized fields so that we can change the value in the editor. Here we can delete the start method because we don't need it. Here we can write something like 0.5 as speed and then exit the prefab mode. In our pipe spawner, we can move the spawn point of the pipes to the right. So we can write something like 5. Let's save that. But before we try it out, let's deactivate the bird because we don't need it at the moment, so it will not fly down. Now we can press play. And you can see the pipe is moving to the left. Perfect. So when we start our game now, we will create a pipe, and the pipe will then move automatically to the left. Forever. That's a problem we need to tackle, of course, but not now. Let's do it a little bit later. Now we want that the pipes are spawning constantly and not only a single pipe in the beginning. There are many ways to solve this problem. Let's implement an easy one. Here in our pipe spawner script, we can create a float variable and call it counter. We can give it a value of 0. Then we create another float. This one is called spawn interval in seconds. It's the time the pipe spawner should wait after spawning a pipe before spawning a new one. We can expose this variable to the inspector with serialized field. Now in our update, we should count up the counter, and if it's more than the defined time interval value, we can spawn a pipe and reset the value. Let's write that. First, we can write the if statement. So if the counter is higher or equal than the spawn interval in seconds, we can then spawn a pipe. And to spawn a pipe, we can just copy the script that we used for spawning pipes from the start method to the update method inside the if statement. when we start, the counter is 0. And here, for this condition to be true, the counter needs to be higher or equal to the spawn interval in seconds. So the counter will not be 0 anymore, but after the pipe has spawned, we want to reset the counter again. So let's write counter is equal to 0 again. So when the pipe was spawned, the counter will be reset. The last thing we need is a counter that actually is counting up. We need to add something in the update method so that it will be added every frame. But on different computers, frames have a different length. So on old computers, a frame can take 2 or 3 times as long as on a new computer, for example. So if we add 0.01 every frame on the fast device, it will maybe take 1 second, and on an old device 2 or 3 seconds. And that's not how our game should work. In our game, the pipes should spawn constantly on every device. But Unity has something for us again. Time.DeltaTime. Time.DeltaTime is the difference in seconds from the last frame to the current frame. So if one frame takes longer because the calculations done in that frame are more complex, the time.DeltaTime will be higher in this frame. The next frame, the delta time can be lower again, and so on. So imagine this frame here takes 0.024 seconds to execute, and that's the value of time.DeltaTime in this frame. And that's the same for the next frame. The next frame is shorter, so the value of time.DeltaTime is shorter as well, and so on and so on. In the end, it doesn't matter how long your frame lasts. If you add a delta time to a value, exactly the time difference to the last frame is added. So when we add the delta time to our counter, the counter will have the value of 1 after exactly 1 second, the value of 2 after 2 seconds, and so on. And I think you can now see what this is good for. So in our update method, we can write counter plus equals time delta time. So now in the update method, we will add delta time to our counter until the counter is higher than the interval value. And then we will spawn a pipe. Let's save that and test it out. Before we test it, we need to set the interval here in seconds on our pipe spawner. So let's set it to 2, for example, and then hit run. And you can see the pipes are spawning at a constant speed. We can also activate our bird again and press play. And now we can already play our game. Somehow. It's not like the real game at the moment, but we will get there, I promise. So pipes are spawning at a constant speed, and we already can play our game, but the vertical position of our pipe is always the same and not random like in the real game. In the next video, we will spawn the pipes at a random vertical position. I hope you liked this video. If you want to support me, please hit the sub button. If you have any feedback or questions, leave a comment. Thank you for watching and see you next time.